So we have a question about a prism. There is a prism which is made of glass and it has got unknown refractive index. Its refractive index is not given. There is a parallel beam of light incident on one face of the prism. Angle of minimum deviation is given as 40 degree. What should be the refractive index of the material of the prism? That is the first part. The refracting angle is given as 60 degree. It is also asked, if this prism is placed in water, refractive index 1.33, what will be the new angle of minimum deviation? We know angle of minimum deviation and refractive index are related see, n is equal to, the equation was sine of A, which is the angle of the prism, plus delta minimum divided by 2 divided by sine of A divided by 2. This is the equation. Okay. But what is this n actually? This n is a refractive index. This n is the refractive index of the material of the prism with respect to the surrounding medium, n21. In the first case, there is a mention of prism, but the medium is not given, so we will take the medium to be air. So n21 is the refractive index of the material with respect to air. A is given as 60 degree, delta minimum is given as 40 degree. So this will give you sine A is 60 plus delta minimum is given as 40 degree, it is 40 divided by 2 divided by sine of A by 2. A is given 60 divided by 2. So this gives you sine 60 plus 40 by 2, that is 100 by 2, sine 50 divided by sine 30. You can calculate this value. This is the refractive index with respect to air. So this will be equal to 1.53. So this is the refractive index of the material with respect to air. Now we have to find the answer for the second part. Second part, this prism is placed in water. What will be the new angle of deviation? In the second part, we are asked to find delta minimum. Okay, let us try that one. In the second case, refractive index of the material with respect to water, because earlier it was air, I took as 1, now this is water with respect to water, and we know this is nothing but n2 divided by n water. This is given by, we calculated n2 was 1.53 by water's 1.33 is equal to sine, angle of the prism is 60 plus we need to find delta minimum divided by 2 divided by sine of 60 divided by 2. So this gives you sine 60 by 2 is 30 plus delta minimum by 2 divided by, this is sine 30. So 1.53 by 1.33 is equal to sine 30 plus delta minimum by 2 divided by sine 30. From this we can calculate delta minimum. Solving this, you will get delta minimum equal to 10.32 degree. So that will be the new angle of minimum deviation. This question is about lens maker's equation. What is given? There is a double convex lens to be manufactured from glass, refractive index 1.55. Both faces have same radius. What should be the radius of curvature for focal length to be 20 centimeter? So it is a double convex lens. So naturally focal length must be positive. So we have f is equal to plus 20 centimeter. Refractive index of the material, this is glass, that is given as 1.55, and this lens must be operated normally in air. So the refractive index of air should be equal to 1. Then radius of curvature is same, that means magnitude of R1 and magnitude of R2 are equal, magnitude of both the radii R1 and R2 must be equal, and we will take it to be R. Okay. Now let us apply the equation. What is the equation? Let us make this equation. 1 by f is equal to n2 by n1 minus 1 times 1 by r1 minus 1 by r2. But for a convex lens we should apply Cartesian sign convention. That means you have a lens like this. Suppose light is coming from this direction. This surface, the first one, this is the first surface, this is the second surface. The first surface has a radius in this direction, so r1 is positive, but the second surface has got a radius in this direction, r2 is negative. So applying this we will get 1 divided by 1 by f is equal to n2 is 1.55 by 1 minus 1 times 1 by r1, we do not know, that is r1. What is r1? r1 is positive r, r1 is positive r minus r2 is negative r. And f is given as plus 20. So this can be written like a 1 by 20 equal to 1.55 by 1 minus 1 is 0.55. This is 0.55 bracket. This 1 by r plus 1 by r gives you 2 by r. We want to find out r, so take the reciprocal. This gives you 20 is equal to, this is 20 equal to, reciprocal of this one is nothing but r divided by 2 into 0.55, and 2 into 0.55 will give you 1.1. Therefore r is equal to 20 into 1.1, that will give you 22 centimeter. That is the answer. So if you have r equal to 22, you will get a focal length of 20 centimeter. This is a question about a virtual object. Okay. There is a beam of light converging to a point P. So you have a beam of light converging to a certain point. Like this point is P. This is light converging. Now a lens is placed in the path of the convergent beam 12 centimeter from P. So from P in the path of the light, see confusion can come, where is this point P, is it on this side or that side? In the path of the light is coming like this. So in the path you place the lens here, somewhere here you place the lens. You place a lens here. 12 centimeter. So let me mark that distance 12 centimeter from here. You select a point. At what point does the beam converge? So when you place the lens, after that will it converge here or somewhere else? Where will it converge? If the lens is convex as well as concave. First case it is a convex. So first case you are placing a convex lens here. And what is the focal length of the convex lens? That is given as 20 centimeter. Question is simple. So there is a light ray coming, light beam coming, you place a convex lens. The convex lens will converge it more. So I say this may converge it more somewhere here, converge more. Now Cartesian sign convention is important. For that the direction of light is important. And what is the direction of light? Direction of light is this. So this direction is taken as positive. Okay. Now all measurements must be from the center of the lens towards that side. What should you calculate? Where is the final image? Where is the final image? So we need to find out what is the value of V. I don't know where V is, so I can't give any sign. But I know focal length. What is focal length? It's 20 but plus 20. Tell me why. Focal length is measured in this direction. Focal length or a convex lens is positive. What is image distance? Tan ta ta. Image distance. Image distance, this is the object. This object is acting like the image. The object distance, not image distance, the object distance U. Where is the object? The first image is acting like the object, that's why we call it a virtual object. So that is 12 centimeter from the lens to the right side. So I will mark plus 12 here. You should know why it is plus 12. Now apply lens equation. What is lens equation? 1 by f equal to 1 by v minus 1 by u. What do you need? You need 1 by v equal to 1 by f plus 1 by u, which is equal to 1 by, what is f? F is 20 plus 1 by u. U is also plus 12. So we get 1 by v is equal to 1 by v is equal to 1 by V equal to 1 by 20 plus 1 by 12, that is like 12 plus 20 divided by 20, this give you 240. So V is equal to 240 divided by 32 centimeter. And if you calculate 240 by 32, 240 by 32, you will get 7.5. You will get 7.5 centimeter. And 7.5, I told you, it was 12 centimeter initially. 7.5 plus 7.5 means from the lens at 7.5. That means the light ray got converged more. Instead of converging there, it converged to this point. So this is the final image. The P will have an image at P dash. So that is the answer. Now we'll do the second part of this. In the second part, what is given? The same thing. We have the converging light. We have the converging light. This is the point P, and at a distance of 12 centimeter, what is kept? We keep a concave lens. So we keep a concave lens here. A concave lens. So when we keep a concave lens, what will happen? The light will not converge this much, it will get diverged a bit. So I expect that the image will go away. Let us work out. Okay, first of all, what is the object distance? Object for the lens is the first image, that point, that is plus 12 in the direction of the light. And what is focal length of the lens given? Focal length is given 16, but understand that this is a concave lens, so it's minus 16 centimeter. And the image distance should be calculated. Straight away, 1 by F equal to 1 by V minus 1 by U. So we want 1 by V, which is equal to 1 by F plus 1 by U. See, you can even use the equation V equal to Fu by F plus U, straight. But for board examination, don't use this. Board examination, go like this. For entrance, always do like this. Okay. Now, what is V? V is equal to, F is given. F is how much? Minus 16. Minus 16. U is equal to 12 divided by minus 16 plus 12. This gives you V equal to minus 16 into 12 divided by minus 16 plus 12 gives you minus 4. So minus and minus cancel. Minus and minus cancel, and you'll get 16 by 4 is 4, 4 12s are 48. So you'll get 48 centimeter, which is positive 48. And where is positive 48? From the lens in the positive direction. So that must be somewhere here. This is 12 centimeter, right? So 12 into 4 times this. So that will go beyond my board. So I'll mark it somewhere here. So what had happened to that light ray? The light ray which was converging to this point, due to the converging diverging lens which went to this point. Now the context of this problem. Connect this to myopia and hypermetropia, because in myopia there was a large convergence. There was a large convergence in front of the retina. You remember, the retina was here. The retina was here, but the light was converging to this point. So you use the concave lens, so it got diverged and focused to the retina. Correction of myopia. And the previous case is the correction of hypermetropia. So when you study myopia and hypermetropia, their correction, do this numerical. That will help you understand what is happening when we insert a lens in front of your eye. This is about a compound microscope. Okay. Before you attempt this one, go through the ray diagram of a compound microscope, because it's important for your board examination. And the second one, you be thorough with the concepts. In a compound microscope, the final image can be at least distance of distinct vision or at infinity. So these two are giving you different magnifying powers. If you study that properly, you will understand that magnifying power when the final image is at D is given by VO by UO into 1 plus D by FE. Negative sign is optional. Okay, even without it's okay. Now if the magnification, the final image is at infinity, this will reduce to VO by UO into D by FE. once you get the values of VO, UO, D, FE, you do not have to apply sign convention here, directly substitute their magnitudes. But to get VO and UO, you may need a sign convention. I will explain that. Compound microscope consists of objective lens of focal length 2 cm and eyepiece of focal length 6.25 cm. So, I can say the eye lens here and the objective lens here. This is a common axis. Eye lens is FE, this is FO. And what is FE given? Both are convex, no problem. So, objective lens has a focal length of 2 cm. This has got a focal length of 2 cm and this has got a focal length of 6.25 cm. Okay. Separated by a distance of 15 cm. This is something that you should be careful about, because in NCERT textbook we have an equation with a term L, and in NCERT L is defined as the distance between the focal point of the, I will call it as F2 of the objective and F1 of the eye lens. This distance is what we call as L in the NCERT textbook. But in this question they are not giving you that L. The lenses are separated by 15 cm. So, they are giving you this as 15 cm. You can find out L, because 15 cm minus 2 minus 6 cm will give you the value of L. But you can see L is not negligible. So, L is not very large than focal length of the objective lens. So, this approximation will not work properly. So, you can't do the approximation. So, you have to use the proper equation. Okay. Now, since that is clear, let me not use L. How far from the objective should an object be placed? This is objective. How far from it? And we know the object is always placed here, between F of the objective and 2F of the objective. Refer ray diagram study. So, object must be here. This is the object. You have to find out this distance. We call it as U, object distance of the objective. So, that is our aim. You need to find out UO. When final image is at D and the second one final image is at infinity. So, let us say final image at D. So, I am taking final image at D. I want final image at D. Who produces final image? Final image is produced by the eye lens. So, I will say final image must be, say, assume that this is somewhere, this is the final image. Assume that this is the final image. Fine, I will call it as H double dash. This distance is what we call as D, which is equal to 25 centimeter. Now, how do we do this? We know the focal length of the eye lens. We know the image distance of the eye lens. So, we can find out the object distance of the eye lens. You can find out U of the eye lens, because focal length of the eye lens is given. How much is focal length? That is 6.25. And image distance of the eye lens is given. How much is that? It is 25. But be careful, we have to apply Cartesian sign convention, because we are going to use the lens equation here. What is the sign convention? Where is light coming from? See, object is here. So, first light will be incident on the first lens. From the first lens, light will be incident on the second lens. So, this is the positive direction. Now, when you are discussing about eye lens, the distances must be measured from this point. So, the final image is here, which is opposite to the direction of the light. So, we can say the final image of the eye lens is at minus 25 centimeter and focal length of the convex lens is positive. So, for the eye lens part, I have two data and one unknown, U of the eye lens. Okay. Now, let us use the equation 1 by F of the eye lens equal to 1 by V of the eye lens minus 1 by U of the eye lens. Substitute values. Okay, no, let us see, what do you want? I want 1 by ue. So I will continue here. This will give me 1 by u of the I lens is equal to 1 by u of the I lens is equal to, that comes here, this goes here. This will give you 1 by v of the I lens minus 1 by f of the I lens, which is equal to 1 by, what is v of the I lens? That is minus 25 with sign convention minus, what is it, 6.25. So this gives you a common negative sign bracket, 1 by 25 plus 1 by 6.25. Okay. Now this will give you minus bracket 6.25 into 25 divided by 6.25, this will be plus, this is like minus bracket 6.25 plus 25 divided by 25 into 6.25. This is 1 by ue. From this you can calculate ue equal to reciprocal. So that gives you 25 into 6.25 divided by 25 plus 6.25, that is 31.25. Okay. This will give you, see, 6.25 will go in 31.25 how many times? 5 times. 5 into 6.25 is 31.25. So this gives you 5, 25 by 5 will get 5, but there is a negative sign here, there is a negative sign here. So you will get the final answer, the answer as minus 5 cent. What is this minus 5? This is the object distance of the I lens. Object distance of the I lens means what is it? What is object for the I lens? The object for the I lens is the image produced by the object. Is the image produced by the object. It must be, where should it be? If you want final image at D, then the first image must be, study that one. It must be within the focal length. It should be between the optical center and its focal point. So the first image must be here. This is the image of this object, first image. If this is taken as H, this is taken as H dash, and this final one is H double. This is created, and this distance is what we calculated. This distance, minus sign, light coming in this direction, minus sign means opposite, that is 5 centimeter. So children, what did you get right now? We got the idea that the first image of the objective lens is at 5 centimeter from that lens. Okay, what is the distance between the two lenses? 15 centimeter. So that total distance is 15 centimeter, in which that image is formed at 5 centimeter from this side. So 5 centimeter this side means it is at a distance of 10 centimeter from the objective. What is that? It is an image produced by objective. So this distance, okay, change color, this distance is 10 centimeter. I hope it's clear. In a nutshell, what did we do? What we did is that we applied lens equation for the I lens. That's it. No, that's it. We applied lens equation for the I lens, and from that I got the object distance of the I lens as minus 5. Minus 5 means this side. So in between the two lenses, where the total distance is 15, I got my first image 5 centimeter from that side, which is equal to 10 centimeter from this side. And what is this 10 centimeter? That is it. It is the image distance of the objective lens is what I got. Image of the object, this distance is 10 centimeter. Now is it plus 10 or minus 10? Now you are measuring it with respect to this point, and the light is incident like this. So you are measuring it from the lens to that point, so that is plus 10. Now children, you know the object, we know the image distance of the objective, and I know the focal length. I know focal length of the object lens equal to 2 centimeter, which is positive. I know VO, I know FO. What is asked? UO. Again use lens equation. Since I don't have enough space on here, I will erase this and we will do this one. Okay, remember this is 10 centimeter, this is 2 centimeter. Let me erase this point. Now I will I will do, this is for objective lens, I am doing this for objective. I am doing this for objective lens. What do I have data? Focal length of the objective is given as plus 2 centimeter and image distance of the objective is given as plus 10, which I got from my first set of calculation. I want u of the objective. Again apply the equation 1 by f of objective equal to 1 by VO minus 1 by UO. So 1 by u of objective equal to 1 by VO minus 1 by FO. I am actually applying the same equation for the objective, which is equal to 1 by VO is 10 minus 1 by FO is 2. Okay, so this will give you 1 by UO equal to 2 minus 10 divided by 10 into 2. I think I will squeeze in here. Okay, 2 minus 10 is minus 8 divided by 10 into 2. This is 10 into 2. So this will go here how many times? 4 times. So this is my 1 by u. 1 by u of the objective is equal to, this is minus 4 by 10. So u of objective is the reciprocal of this one, which is minus 10 by 4, which is minus 2.5. Arey wah. Minus sign means what? From the lens opposite to light. Light is going in this direction, so that must be in this direction, minus 2.5. And where will this minus 2.5 fall? We know the focal length is 2 centimeter. And if you focus here, please focus here. If you focus here, you know the object must be between FO and 2FO. We know FO is 2. So this focal length FO is actually 2 centimeters. So this is 2 centimeter. This is 2 centimeter. I think I should erase this a bit. Okay, I will erase this a bit so that you can understand. Okay, this is 2 centimeter and this is 4 centimeter. That's what f and 2f, and your value is 2.5. So you are exactly here, 2.5. This is 2.5 negative. So we got the answer for the first question. The object must be placed at 2.5 centimeter from the objective lens to get the final image at D, and this will give you the largest magnification. Now you can even calculate the magnification there because we have all the data. Okay, let us work out the magnification also. This part is done. I think I will erase this. I will calculate the magnification. So what is magnification? Magnification is given by minus VO by UO into 1 plus D by FE. I told you don't apply any sign convention. What is VO? Take the magnitude. V of the objective is how much? It is 10. What is U of the objective? U of the objective is how much? It is 2.5 into 1 plus D is 25 and FE is 6.25. So this gives you minus 10 by 2.5 give you minus 4 into this give you 1 plus. You can see 25 by 6.25 is again 4. This is 1 by 4. So this is 5 into minus. This gives you minus 20. So the magnification produced by this system for the case A is 20. That means any object of size 1 centimeter will be seen as an object of 20 centimeter. Minus sign means inverted image. So this is the magnification that we normally write as 20x in microscope. 20x. So that is the first part. Now we will do the second part. I hope the first part is clear. You work out the first part, then only work out the second part, because without understanding the first part there is no meaning in doing in the second part alone. Okay. In the second part, what is given? You have your eye lens, you have your objective lens. So this is your eye lens with focal length 6.25 and this your objective with focal length 2 centimeter. And what is asked? The final image must be infinity. And who produces final image? That is your eye lens. And final image is produced by eye lens, which is a simple microscope, only when its object is at its focal length. That means you measure 6.25 here, this point 6.25. When the first image is formed here, at 6.25. I will tell you again, the eye lens is a simple microscope. It will produce a final image at infinity only when its object is at its focal point. And its object is the image produced by the objective, and that must be at 6.25. And we know the total distance is 15. So you can see this value, it is 15 minus 6.5. Fine. So what I am going to give you is that final image at infinity, second part, final image at infinity. Therefore, u of the islands is equal to minus f of the islands. Check it. U of the islands is the negative 6.2, because light is coming in this direction, that should be negative, and that is equal to minus 6.25. Okay. So what is V of the objective? What is V of the objective? See, when you want to find out this distance, don't apply sign convention. You know total is 15, this is 6.25. So V of the objective is nothing but 15 minus 6.25, which is equal to 8.75 centimeter. So wait, 8.75. And what is the sign convention with respect to the objective lens? It should be in the positive direction. So we get VO is equal to plus 8.75. So the difference between the previous section and this section is that in the previous section we calculated VO using the lens equation, but here we have a very simple concept that the final image is at infinity. So the first image must be at the focal point. That's why it's easy. Now using what is focal length of the objective, that is given as plus 2. Now you can find out 1 by f of the objective equal to 1 by v of the objective minus u of the objective. Work out. Now 1 by u of the objective equal to 1 by v of the objective minus 1 by f of the objective, which is equal to 1 by VO. VO we know it's 8.75 minus 1 by 2. Okay. This gives you 2 minus 8.75 divided by 8.75 into 2. This is 1 by u of the objective. So from this, u of the objective is equal to 8.75 into 2 divided by 2 minus 8.75 is minus 6.75. You divide this and you will get, I'm sorry, I'm using my calculator. You are not supposed to do that one. This is 8.75 into 2 divided by 6.75, which will give you 2.59 approximately with a negative sign. So where is it located now? The previous one, you know, it was at 2.5, this is at 2.59 here. So if I draw this diagram here, focal length is 2, so focal length will be at 2, 2 times focal length will be at 4, and this is negative for this lens. Light is coming in this direction, this is positive, negative means to the left side, that means 2.59 somewhere here. So if you compare the previous one and this one, in the previous one, eye lens here, objective here, object was at 2.5. Final image was at D. Now you move it a little away, 2.59. Final image is at infinity, relaxed vision. So this is it. Now how do we calculate the magnification? Magnification when the final image is at infinity is given by minus V of the objective by U of the objective into D divided by F of the objective. Okay. Now this can be calculated like a minus, what is V of the objective? You know, V of the objective is given by 8.75. 8.75 divided by U of the objective we calculated. U of the objective is now is approximately minus, I'm sorry, is not minus, divided by 2.59 into D is 25 divided by 6.25. If you calculate, you will get this approximately, as 13.51 with a negative sign, 13.51 negative sign. Okay. Now what is the meaning of minus 13.51? Minus means inverted image, and 13.51 is a magnification produced. That means this is producing 13.51 times magnification. The previous was 20. So I told you, when the final image is at D, you get the maximum magnification of 20. When the final image is at infinity, relax the vision, you are happy, you are a happy soul, but the magnification is 13.51. Okay, I suggest that you strongly practice this question, work out in detail, and also at the same time simultaneously you study the theory. Draw the diagram, study the theory, read that, read this, read that, do this. Then you will become okay with any question in microscope. Any question in microscope can easily be done when you practice this. There is a power of this question in NCERT. It is a very powerful question which gives you a detailed X-ray vision of a microscope. Do that.